In problem number 1, we have a problem involving a business selling wind chimes, and we know that we have 1,000 sold for $100 each, and it's estimated that if the price decreases by $20, the monthly sales will increase by 200. So what I've done is I've written those as coordinate points here, with the number of chimes as the first coordinate and the price as the second coordinate, because to get a price function, which is what we need, because this problem is asking us to find marginal revenue. So in order to find revenue, remember we need to take price and multiply it by x. In order to find a price function, in this case we have 2 points of data that tell us a x value, a number of items, and a price. So in order to find revenue, like I said, we need a price function times x, and to do that we need a price function. And we can see here that this price is changing linearly with respect to how many things are sold. So we just need to find the equation of the line that goes through these 2 points. That will be our price function, and from there we can continue on with the problem, eventually finding the marginal revenue. So in order to find the equation of this line, we first need to find the slope. So our slope would be, I'll put -20 on top because our y values, our price went from 100 down to 80, and our x went from 1,000 up to 1,200. So that's 200. We get one of the zeros to cancel out, -2 over 20. In other words, -1/10. So then to find the equation of the line, we can just use y equals mx plus b given one of those points, and this slope, I'll just use the first point because that's simpler. And we would get the y is 100 equals m times x, which is 1,000, plus b. And you can see there we can just solve for b, and then we'll have the equation of the line. So -1/10 times 1,000 would be -100, and if we add that over, we'd get that 200 is b. So therefore our equation, our p of x function, is going to be -1/10 x, because that was our slope, plus 200. So this is our price function. So we need that to answer the question. So part A says, what is the marginal revenue? So we need to find a revenue function. Well, a revenue function is always if you just take your price function and multiply it by x. So our revenue function would be -1/10 x squared plus 200x. So that was just multiplying the p of x line times x. So there's our revenue. And part A is asking us to find the marginal revenue when x is 1,100. So marginal revenue is the derivative of revenue, so r prime. So the derivative here, using our power rule, this would be -1/5 x, because we would bring the 2 down, but the 2 and the 10 can reduce to 1/5. And the derivative of 200x is 200. So there's our marginal revenue function, -1/5 x plus 200. And then all we need to do is plug in our value of x, which was 1,100. So we get -1/5 times 1,100 plus 200. So 1,100 divided by 5 would be -220. Plus 200 gives us -20 for our marginal revenue. So part B is asking us to continue with this problem, but now we're kind of doing a related rates problem instead. Because it says, suppose the company is increasing production of chimes by 15 per month. So right there, you should be aware that this is going to be a related rates problem, because that quantity, 15 chimes per month, just added time as a component to this problem, where none of this had anything to do with time so far, right? Our only variable was x, which was number of units, and we've had price and revenue and things like that. No time anywhere, but it's adding it now, so that's going to be a related rates problem. So we're increasing the production of chimes by 15 per month. Find the rate at which revenue is changing with respect to time when production is at 500 chimes. So we're still going to need this price function and revenue function because we need to find the rate at which revenue is changing. Which means even though we're doing a related rates problem, we're still going to have to use this function. So we want the rate at which revenue is changing with respect to time, so that means we want dr dt. So we're going to be taking the derivative of this equation, r of x, but we're going to be taking the derivative with respect to t. So that's going to give us that dr dt is equal to, now let's take the derivative here. So this derivative is going to look almost the same as the previous step, except that every time we take the derivative of something that involves an x, we have to multiply by dx dt. So the derivative of this term was negative 1/5 x, but now it's times dx dt. And the derivative of 200x was 200, but now it's dx dt. So our derivative looked pretty similar. We just have that extra dx dt term. So we're looking for dr dt, which means we need to know everything else, which means we need to know x and dx dt. It said find the rate at which revenue is changing with respect to time when production is 500. So we know that x is 500. And dx dt is actually given to us from the first part of that. Suppose it's increasing its production by 15 per month. So that means x is increasing by 15 per month. So since everything here was per month, our dx dt is going to be 15. 15 chimes per month. That's the rate at which x is increasing, the dx dt. So now we just plug those numbers in. So dr dt then is equal to negative 1/5 times 500 would be negative 100 times dx dt, which is 15, plus 200 times dx dt, which is also 15. So negative 100 times something plus 200 times something is just 100 times something, and 100 times 15 is 1500. So that is the rate at which our revenue is changing with respect to time when x is 500 and if the rate of change of x with respect to time is 15.
The Teaching Center, UF's Learning Resource Center.